So I'm at that point that sometimes happens when I'm editing video, realizing why I didn't do something. And so I'll preface this real quick with the question that's probably going to come up: why didn't you just restuff the cans? Yeah, I probably could have just restuffed the cans. I just had it in my head that I wanted to use terminal strips and that it would work better. And I kind of hate restuffing cans. 4 sections, it gets tight. But yeah, I could have done that. I just elected in this case to not do that. I've restuffed cans before, but I didn't here. I love the smell of vintage electronics, don't you? It's a very distinct smell. They just have that. I don't know if it's from smokers or just the vintageness of it. Bakelite. So we're going to do a few things today on this. The horizontal phase detector diode, that's this right here, is going bad because I'm getting jittering in the horizontal. That's what those selenium diodes do. I got some 1N4148s, I think is what they are. They're just general signal diodes. I picked up a bag of those pretty cheap, and I got the American-made ones, not the China ones. Some old stock. So we're going to change that, and while we're in here, I am going to at least change the vertical electrolytic because I have it. It doesn't necessarily need to be changed, although there is something weird with the vertical. Every once in a while, the vertical shrinks just a little bit. It kind of does that and then comes back, but it does it pretty rarely. I doubt it's that cap, but I have new caps for this. I think I mentioned the last time that we worked on this, which has been quite some time now, that one of the electrolytics is bypassed in it. One of the sections, I think it's this can, and it's domed on top. I'm using this thing actually quite a bit. I'm using it more than I should, really, because it uses a shitload of power, and I don't want to lose the tube. But if you don't use it, what's it going to do? Sit, and then the tube is good someday? For what? If you're going to look, if you're going to use it, you're going to use it. I guess I could find another tube. So, anyways, let's get on with it. We'll set up and do the diode first, and then there's a couple of those ceramic white capacitors. There's 2 of those I think I need to change. I got some Nichicons to replace those. We'll do this one, and then we'll probably tackle this last. I'm just not looking forward to it. It's quite a bit of work. And here's what we got. These, like I said, are 1N4148s, just general signal diodes. These will work just fine. You want your anodes on either side right here, and both cathodes combined to come out the center, just like what's in there already. Obviously, that's how this works since it's a detector. So we'll go ahead and just remove this. RCA tells you in their service manual to cut the components off the board and replace them that way. I think for this it's better to desolder it and insert this. So I'll just bend both anodes down and we'll get it installed. All right, there they are right there, installed. Can't get this camera. This camera doesn't focus very well when it's close. But anyways, they're in there and pretty easy. So that should work just fine. There they are right there. I trimmed the leads back already. So we want to change this guy, and we want to change this guy. And I did get the appropriate 2000 volt capacitors for those. So I tested this guy, and it's not bad as I suspected. There were no symptoms of it being bad, but these are a known failure point. It's gone down a little bit in value, but only by about 50 picofarads. That's not going to matter for this, but I did change it out. And by the way, I do just want to say I'm not changing caps just to change caps. I'm changing them because there are known failures in these things. And there's already one that's been bypassed right here, one of the electrolytics, and I'm using it a lot. And I really don't feel like having to come in and replace stuff as it goes. Now this one right here, this is important if this is going bad because that can cause the audio output tube. I believe that goes the audio output tube. I went through and I figured out what these were for before. This is in the vertical circuit, and this is for the audio, I think. But I forget exactly, but I remember determining that it was more important to replace those. The discs obviously don't go bad. This is going to be kind of a nightmare up here. There's a lot going on down in here in order to recap this. and I'm really not looking forward to it. There's a cap, there's a little disc cap on there, and there's a resistor here, and obviously this is going from ground to the square section in that middle electrolytic, and that's the one that's all domed on top. So obviously they got to go. They got to go because I'm using it a lot, and eventually they're just going to go bad. So let's get them changed out, and I'm going to come up with a plan here to do these with some terminal strips. Got these guys right here. I've got to double check and see if there's a doubler circuit in here. It doesn't look like it because the caps are all grounded, so it should be where all of them can just be common to the terminal strip common. So we're headed for the vertical circuit now, and this is the one that I couldn't remember in the last video. That I had looked up the actual part number for it, TVA1414, that's in the SAMs, and you know it's still available. So I bought it, and it is actually the replacement for the Sprague that's in here. That part number there is this part number here. So this is what it looks like now. Of course, it's a modern electrolytic, but that's what it looks like. So I'm going to desolder that one from the board as well and get it out of there. Like I said, I don't think that it's bad. It might be going bad, but the set works pretty darn good the way that it is. But this is just more of a preventative maintenance kind of a thing. Now, these don't usually go bad, but let's find out. Haven't tested it yet. Yeah, it's not bad. It's tired. So it's gone up to 65 microfarads in capacitance, and its ESR is 1.7. That's not too bad. So it's on its way, but it's not bad. Let's compare it to the new one. All right, let's see here. Interesting. So this brand new one, of course, it has a lot less voltage loss, but it's got an ESR of almost 4 ohms, which is interesting. It's reading 44 ohms or 44 microfarads. So I wonder if this is like old stock or something like that. I don't think the ESR is a big problem in this circuit anyways, but that's interesting. Let's compare it. I bought 2. Let's compare it to another one. All right, we're testing another one here. I'm also wondering if it's my leads, because obviously I can't get the leads into these things very easily. This one's 2.647. This looks a little bit better. We might use this one. It's a little happier. Let me take these leads out of here and hook it right in there and see if that changes anything. All right, let's try that. Yeah, big difference. Interesting. So 0.8 ohms ESR, which is great, and almost no voltage loss. Boy, that does make a big difference. But, you know, if I can't put them in the tester, I can't put them in the tester. Sometimes you got to use leads. So I wish I could test this one. It's too short, which is too bad. But obviously it's on its way out. It's got some voltage loss. Okay, so we're just going to take this real easy, and we're going to do these one section at a time, or one cap, multi-section cap at a time. The first one's only a 2-section. The original is an 80 microfarad at 450 volts and a 2 microfarad at 350 volts. Obviously, values aren't what they used to be. So we have a radial cap that's 2.2 at 350. That's perfect replacement. And an 82 at 450, and I think I got a bunch of these probably because there's more in other sections. These are good Nichicon caps. I did go through and hand pick every single replacement. Some of them, like I said, are not exactly the value. These are, it might as well be the same value. These might as well be 82, 2.2. It's not, first of all, it isn't that critical, but you know, these are as close as you're going to get. So these should be pretty easy. That's these two right here. Boy, it's hard to see in there, but right there and there. And I'll have to look and see. There's half circle and triangle. I have to see what those two are. And then there is a little disc cap that's on here. I'm going to have to transfer this over to a terminal block. Now, the biggest challenge is going to be figuring out where this stuff is going to go. I don't want to remove the caps from the chassis, so I'm going to be extending wires almost for sure here to get this stuff into a place where it can live. You know, I may put one here, may have to pull the wires through these holes here. I'm really not sure yet. Let's play a little Tetris and see if we can figure it out. So here's where we're at with the first one. So this is where it's going to end up. It's only two of them. You notice there's a 1,000 picofarad disc cap back there. That's where it was there. So I'm just hooking it back up the way it was. I'm just kind of Chinese blueprinting this. I've got the schematic if I need it. But anyways, this is going to be my 82 at 450, and this is going to be my 2.2. And these are wire wrapped on here, unless they've been worked on, which some of these have. But the ones that are wire wrapped, we're going to undo that wire wrap. If you don't know what wire wrapping is, that's an old school way of doing connections with no solder. But that's what these are. So I'm going to unwind it, and I'm going to splice it and put some heat shrink tubing on it. That's just the best way to do this. And this one's pretty easy. It's only 2 sections. I don't know what I'm going to do with the 4-section ones. I don't know where I'm going to put them. They're going to have to go on top somewhere probably. They can't live down here like these do. So I'm just going to have to try and make the best out of this. All right, so we got the first 2-section done. Not my best work, really not. I'm not happy with this. I actually might route this a little bit better. I just pulled the wires out so I could get to them, and they're kind of floating. I was hoping to be able to get them hooked under here, and I can't. But I don't know. It just didn't come out. Didn't come out my best work, but we did get it in here. It's hooked up correctly. I verified the connections. So now I can move on to the next 4-section. It's just going to get real tough here. So I ended up doing what I didn't want to do, and I removed at least this cap out of the way. This looks original too, 4166, so that'd be 1966 41st week, if that's correct. And the 80 microfarad is got like 10 ohms ESR, and it's like at 150 microfarad, so it wasn't long for this world. I'm kind of glad I'm doing this. But yeah, now I got this space here. I can put some terminal strips. I got some room to work on the other side, and I can bring some of the wiring that I need to bring down here to get to these guys. You know, this is going to be a headache because there's a resistor here and a resistor here. It's got to go around. This will obviously come off. Don't need that anymore. I got a new one to replace it. This is just a bypassed cap, 45 or 47 microfarad in place of a 30, which is fine. So now that I can pull things kind of through here and maybe mount a terminal strip up top here, or a couple of them, we can start bringing wires around. Okay, so we get the middle cap here. 80 at 450, 30 at 450, 20 at 450, and 40 at 150. Let's come down here. So we're going to do an 82 at 450, a 33 at 450, so that's replace the 80 and the 30, the 20, 22 at 450. The only one that's a 160 volt rated is the 40. They've got it as a 40. We're going to put 47 in there. So these will be the 4 replacements. So here's what I've done for the first 4-section. This is the 80, 40, 30, 20. And I just soldered it to the terminal strip. It doesn't fit real well because there's 4 of them on a 5-lug terminal strip, but that's just the way that it goes. And then I just soldered some leads to it. So it's kind of like a 4-section can almost. You know, now I've got wires as my terminals, and I can bring these wires back through the bottom, because the problem is there's 2 wires on that one, and 2 wires on that one, and a resistor and a wire on that one, and a resistor and a wire on that one. So the only real efficient way for me to do this is to bring this, attach it to the other side, bring the wires through, and match each one to the wires here, and heat shrink, solder them together and heat shrink it. That's really the only efficient way for me to do this. To say that this has been challenging is an understatement. I did have to go ahead and pull this can out. I might pull the last can out just because it wouldn't make sense, but we did get the second 4 section has been totally recapped. I'm not super happy with this, but it's the way it's got to be. There's no room to put terminal strip in here. So I'm going to have to probably zip tie some of these together to keep this stuff from flopping around. This resistor will go up in between 2 caps, so that's why that's like that. But I marked the leads so I knew which ones were which once I got it installed. But here's what it looks like on here. It's not the most pretty thing in the world. I really don't like it, but it's just no way to do this. So we got one more 4 section to go. And I got to looking at this one. Boy, is it hard to see the markings on the bottom of it. They're actually part of the phenolic, and you can't really see it, but there's like a half round there. That one's not marked. That one's like a triangle on top, and that one's a square. But it's just a cutout as part of the phenolic. It doesn't have like a clear marking on the bottom like these do, where these just, you can see it's got a clear marking. These are better. By the way, too, you can see where this one, the section, shot its jizz out right there. So it's no good. Definitely that one that was bypassed, that 30, is just, it's totally open. So anyways, I just got to kind of keep going at this here. It's very, very challenging to work in here. You can see there's another resistor that I'm going to have to get hooked up. Maybe now that there's some room under here, maybe I can put a terminal strip under for the rest of these. I'm just not sure yet. But this is a big undertaking. You know, be prepared to. It's not hard, but this is, you just got to have a whole lot of patience. Okay, so here are the last 4. 82 at 450, 56 at 450, 22 at 250, and 56 at 50. Obviously, it's replacing a 50, a 20, a 50, and an 80. So we're getting there. I put together the last 4. There's the leads for it. I'm not particularly happy where they ended up for right now. I just mounted them in a screw that's already in the IF cover, the strip for the IF cover. It's not a good place for that because we got power right next to the IF strip, so I might move that around once I get this all hooked up and I get this last can out of here. Once I can 86 that can, we'll find a place to put it that might be a little bit better. I've got lead length to kind of move things around a little bit. So let me detach one section at a time here. I'll probably do the one where the resistor needs to go over to here first, which is right here. I think that's the 80 microfarad section here. And we'll just work our way around one at a time. That's real important. Don't disconnect a whole bunch of them. You'll lose track of the wires. You could try and mark them, but that's a headache. Just one at a time. I'll tell you what, I'm debating whether I even want to release this video. This is such a rat's nest. I don't like this at all, and there's just no room in here. But we did get it all hooked up. So, you know, basically every single one of these pieces of shrink tubing is a connection to the leads that all the different B pluses needed to land, and there's no room for a terminal strip in here. You know, there's one unused one there. I could probably squeeze one in here somewhere with the power transformers all right above it. I can't screw it in anywhere. So I don't know. It'll be in, by the way, it'll be amazing if this thing even works after this. I mean, these things are so fussy that, you know, I've changed a whole bunch of capacitors now, and yeah, it's just, who knows. Anyways, I did get the terminal strip in right here, and terminal strip, of course, this one here. So this is just how this stuff is kind of ending up going. I'm not, like I said, I'm not super proud of it, but it's functional. You know, this isn't about beauty, it's about function. So I'm just going to go around, I'm going to check it for shorts. I'm going to use my meter just to make sure I don't have anything dead shorted somewhere. I didn't screw anything up, and then we'll probably bring it up. I don't know, maybe I might bring it up on a dim bulb. I have to bring that into the house to do that. So, you know, we'll give it a shot here in a few minutes. All right, let's just do a real quick resistance check here. So this is to ground on this set right here. So that's good. We got solid connection there. And this is to... it's going to be hard to tell you which caps are what, so yeah, that's good. It's going to move all over the place as the caps charge up and stuff. So we're good there. Good there. There's no short. This should be ground again. And what do we got here? 313 ohms, so that's got a resistor in it somewhere. 5K, 6K, yep, that's charging up the cap. Check a ground here. Okay, we're good. This is the second bank of capacitors, terminal strip, whatever you want to call it. 1 meg and falling. It's very difficult to get to some of these. Let's see if I get to the second one here. 4K, 6K, yep, that's cap charging. We'll skip over the ground. 1 meg and falling. And whatever this last one is. So we don't have any shorts. That's the important thing. 3K and climbing. Perfect. All right. Well, there's no shorts, so I'd say it's probably safe to for us to plug this thing in. I might bring a dim bulb in with me just in case, but I don't think that it's going to be a problem. Okay, chassis is back in the TV. I think I got everything hooked up. I always feel like there's more than there is, but there isn't, so should be good to go. Pulled the power switch up already. I've got the dim bulb in here. This is only a 60-watt light bulb, so I expect it to be pretty bright, but it should come up and kind of dim down a little bit. It's going to really current limit it in case I really shorted something or screwed something up somewhere. So I got the power strip on already, and we're in series with the bulb. So let's take a look and see what happens. That bulb is on full bright. So the question is, did I short something? Or is it just because it's a 60-watt light bulb? So I might step it up to 100 here. All right, I stepped up to 100-watt light bulb here. So this thing's probably like 300 watts, so I don't know. I'm still not sure unless I bump it up a little bit. It's still got the circuit breaker in it too, just in case. So it should be all right. And it's the bug kind too. You know, those are good ones. Let's see what happens. Yeah, that's full brightness, huh? We got something shorted somewhere, I'm pretty certain. I'm going to have to... I'm going to have to seriously take a look at the bottom of this chassis again and see what I missed. Okay, so I just took a really close look at everything. I don't see anything odd, and I know I was really careful with this thing, and, you know, I'm thinking about it. This thing's 320 watts. 100-watt light bulb ain't going to cut it. It just ain't going to cut it. You know what? Let's just feed this thing the onions, huh? Let's see. Turn the switch on, turn this off, plug this in. I heard the degaussing. Circuit breaker didn't pop. I see filaments. I hear audio. I don't hear... Oh, there's high voltage. I just heard the horizontal start. Would you look at that? I'll be damned. You mean I didn't screw it up in the first shot? Let's feed a signal into it. All right, just turn the converter box on. Would you look at that? It works. I'm actually kind of shocked. I just assumed the colors are all off and everything. I think I'm going to have to... I've been playing with the controls, obviously. But, well, I don't know if that's not a success story. I don't know what is. I'm just shocked. Last time I took this chassis out of here, I barely touched it, and the thing just went totally nuts on me. It took me 6 hours to get it working after that. So that's kind of a nice surprise. Well, now that I've got horizontal and vertical deflection and audio and takes a signal and everything, I guess I'll just bolt the chassis back in and clean up all the rest of the wiring. All right, we got it all back together, and man, what a performance difference. I just didn't expect it. Just didn't expect it. It used to kind of make some funny noises when you'd turn it on and the tubes were warming up, but it's not doing that now. So that's great. The degaussing is working too because it's quieter for some reason. I'm not sure why. So yeah, it vertical deflection's better. I need to adjust the yoke a little bit. Somehow I turned the yoke, so I'll do that. But the picture is just much better. Of course, the news is littered with 9/11 since it's September 11th. But news is good because it doesn't trigger content identification. So, anyways, yeah, I think this thing's it's looking good. We'll run it for a while just to make sure something doesn't show up. But yeah, it looks excellent. It looks a little washed out on the camera, at least on the screen on the camera right now. Who knows once I get it on the computer, that there's a sliding door and a lot of light coming in, reflecting off of the glass right now. So, it's coming through right there. It definitely looks like an excellent image. So, this was definitely a tedious one, not difficult, but you have to pay real close attention to what you're doing and don't screw anything up. Don't lose track of what you're doing. You got to just keep focused, and you'll be able to do it. And it's a lot to recap. Let's see, what was there, 10 caps, 10 filter caps in there, plus the vertical and the other two ceramic caps that are the ceramic paper caps. So it's quite a bit of work to do a CTC16 or CTC16XL, which is what this is. I think the CTC16 chassis is probably basically the same. But I think it's well worth doing if you're going to use it, because I can tell a performance difference. It sounds better, it looks better, so well worth the effort. What an incredible picture this thing has. I mean, just amazing for a television from 1966. It just looks amazing.